Okay, this first video is about the states of matter. You can see that here we have the solid state and the particles are just vibrating, and they are regularly arranged and there are no spaces as such in between them. When we just heat it, that is when we increase the temperature, those particles will gain kinetic energy. They'll move faster and they'll turn into liquid state. Now, in liquid state, they are in the form of bunches, you can see, and they can move past each other. And now they are not regularly arranged. Now, if we increase the temperature a little bit higher, so these particles will gain more energy and they will move away from each other and they will turn into gas. Right now, just you can see that the particles are far away from each other. They are having the maximum freedom, no forces in between them, you can see, right? And they occupy the maximum space and they have indefinite volume and indefinite shape. So this is how we have the different conversion from solid to liquid. We called it melting, and from liquid to that's gaseous state, we call it evaporation or boiling, right? Now the next one is about the diffusion process. What is diffusion? Diffusion is basically the random movement of the particles. So if a person is standing over there and we have the burger in the box, right? So if I just, we cannot smell that the burger is there in the room, but if I remove the box, so these are the smell particles, the aroma particles, right? And now that person can smell it. Now the next one is about nitrogen dioxide, that is NO2, which is brown in color, and we have two gas jars. In the upper one we have air, and in the lower one we are having the brown nitrogen dioxide gas. So if I remove the barrier in between these two gases, or in between these two jars in which one air is there, now there is a random movement of the particle of nitrogen dioxide and air as well. So now you can see that brown color becomes lighter and it spreads throughout the container. So this is diffusion. Diffusion is a very important process by which we can smell perfumes, we can smell the other things as well, because the particles are in continuous movement. Now the next one is about these two gases which are represented by different colors. If we remove the barrier in between these two, you can see those two different gas particles are just moving up and down randomly, and we have a mixture of both the gases. And you can see all these particles. The first one is the solid, they are just vibrating. Second one is the liquid, they are moving past each other. And the gases, they are moving everywhere, all around whatever the space is given. So that's why solid has a definite volume and shape. Liquid volume is definite, but the shape is not definite. It takes the shape of the container. But while when we talk about gas, it has indefinite shape and indefinite volume. We were talking about the rate of diffusion. Now, about the diffusion. The rate of diffusion is the speed of diffusion. The speed of diffusion is dependent on two things. One is the temperature. If the temperature is higher, diffusion rate is faster. You can think of the way we can smell of the garbage more in the summer season when the temperature is higher, right, than the winter one. The second one is their masses. If the mass of that compound or the gas is lighter, it diffuses faster. So here we have a glass tube. One side of the glass tube we have a cotton soaked in hydrogen fluoride, that is HCl. Its MR is 36.5. On the other side we have cotton wool soaked in ammonia. Formula is NH3 and MR is 17. So you can see that ammonia particles are lighter, right? Now we just see the gas flow. They are going to react, but not in the center. Why not in the center? Because the ammonia's MR is higher, so it travels more distance in that time than HCl. So here in the center, ammonium chloride is produced because ammonia and HCl, they react together and give us ammonium chloride, which is white solid. So after few minutes we'll observe white solid which is not in the center. It is away from ammonia because ammonia's MR is smaller, so it diffuses faster. Okay, that is all about the animations of uh, particle nature of matter.